Imagine discovering an ancient artifact and being able to pinpoint its age with incredible precision, unveiling stories from thousands of years ago. That is the magic of radiocarbon dating, a technique that has transformed our understanding of the human past. But what if those precise dates sometimes whisper tales that are not entirely accurate, leading archaeologists down the wrong path? While immensely powerful and revolutionary, radiocarbon dates are indeed sometimes unreliable due to a complex interplay of scientific assumptions, environmental variables, and archaeological context. It is not a perfect time machine, and understanding its limitations is as crucial as appreciating its capabilities for accurate historical reconstruction. The core mechanism of radiocarbon dating relies on the predictable decay of a radioactive isotope of carbon, carbon-14, in organic materials after an organism dies. However, the fundamental assumption that atmospheric carbon-14 levels have remained constant throughout history is inaccurate. Fluctuations in Earth's magnetic field, solar activity, and even the burning of fossil fuels have altered the concentration of carbon-14 in the atmosphere over time. This necessitates the use of complex calibration curves, which translate raw radiocarbon ages into calendar years, but these curves are continually refined and can introduce uncertainties. Additionally, samples can be contaminated by modern carbon or much older carbon, significantly skewing the results. Furthermore, the phenomenon known as the reservoir effect can occur when organisms obtain carbon from sources other than the atmosphere, such as marine organisms absorbing carbon from oceans or freshwater organisms from hard water, which often contains older carbon. This can make the sample appear artificially older than its true age. For archaeologists, this means never treating a single radiocarbon date in isolation. It is imperative to meticulously assess the archaeological context of the sample, ensuring its clear association with the event or artifact being dated. Always consider whether the organic material itself is prone to reservoir effects and whether potential contamination might have occurred during excavation or analysis. Seeking multiple dates from different samples within the same archaeological layer, and even employing other dating techniques like dendrochronology or thermoluminescence, can help cross-validate results and build a more robust chronological framework. Understanding these nuances allows for a more sophisticated interpretation of the past. For example, the marine reservoir effect is a well-known challenge, meaning dates from shell or marine mammal bones might need a specific correction factor that varies regionally. There is also the old wood problem, where dating charcoal from a long-lived tree could give an age reflecting the tree's growth rather than the fire event itself. Recognizing these specific issues and their implications helps archaeologists interpret seemingly anomalous dates and refine their chronological models, making our understanding of ancient societies much more precise. By appreciating the dynamic nature of carbon-14 in our environment and the potential pitfalls in sample collection and analysis, archaeologists transform a powerful tool into an even more reliable one. This critical approach to radiocarbon data allows for the creation of more accurate timelines for past human activities, ultimately enriching our narrative of human history and cultural development.